Hey you, do you want some code?
Welcome back. Why do we learn all of this? Well, because now we know a critical part of being a JavaScript programmer. We want to write a code in a way that helps a compiler make optimizations. We don't want to work against it and slow things down. Throughout the rest of the JS Foundation course, we are going to learn different ways to write efficient code. But I want to give you some basic things to watch out for when we're working with the JavaScript engine. Now, keep in mind that most of these things I'm going to show you will seem like things you don't really use or see that much anymore. And that's because most developers don't use them since they can be bad for optimizations. But it never hurts to know what they are. It doesn't mean that you should never use them, but that the use cases for them are very, very rare. So here's the list. In order to help the JavaScript engine, we want to be really, really careful with these on the left. Functions that directly call the eval function, which is included with JavaScript, can be very problematic. We will discuss arguments when we cover functions in this course. It is something that is inherent to every function. There are many ways that we can use this keyword in JavaScript, but there are also many ways that make compilers able to optimize it. So we have to be really careful when using arguments. And I'll show you later on how can use parameter destructing to avoid using arguments. Or in loops, for example, when looping over objects can also be problematic sometimes. So I like to use object.keys and iterate over the object keys. That way, the with state, which is not commonly seen in the wild anymore, is another problematic one. Additionally, the delete keyword in JavaScript can be problematic. Now, I'll provide you resources in the links below for you to read if you really want to dive deeper. But there are two main things I want to discuss here. There are primary reasons why these things in JavaScript can make our code less optimized. Let's take a look. The first thing I want to talk about is something called inline caching. We can demonstrate inline caching this way. Let's say we have a function called findUser that takes in the user parameter. This function will simply return a template string saying found. Let's assume a user has the first name and the last name. Here we can create an object called userData that will have the first name as Johnson and the last name as Junior. Now, all we need to do is call the function findUser and pass it the userData object. Now, inline caching does something really interesting. Due to inline caching done by the compiler, code that executes the same method repeatedly. Let's say the findUser method or function is being called multiple times. Well, the compiler can optimize this so that whenever it's looking for the user data, which has the first name and the last name, it can use something called inline caching. Instead of looking up this object every time, finding the key that the first name and the last name and then the values, it will cache or inline cache them. So the findUser just becomes this piece of text. If we call findUser repeatedly, we would just replace the with found Johnson Jr. because at the end of the day, that's all that function is doing. Another important optimization for compiler code is something called hidden classes. Many of the gotchas that I showed you previously, such as delete keyword, really affect these hidden classes when it comes to compilers. Let's have a look. If I had a function, let's call it animal, that receives x and y parameters, and we'll use this keyword for now. We are going to learn more about that soon in this course. Don't worry. But let's say we just have this animal with X and Y properties. And now we create a new object. Let's say object 1 is going to be a new animal that takes in 1 and 2. As a property doesn't really mean much, but there is our first object and then our second object. We'll do the same thing, but this time with different parameters, 3 and 4. Now, the compiler is going to take a look at this time and say, alright, we have an animal that we are creating here, and we are assigning to object 1 and object 2. But if we go ahead and add object 1.a equal to, let's say, 30, and then object 1.b should equal 100. And I'll do the same thing for the object 2, except this time for the object 2, I'm going to create it in a different order. So I'll add the b property first and then the a property to object 2. Hopefully that's not too confusing. That code will actually make the compiler run slower or de-optimize the code. This is due to something called hidden classes. You should try to instantiate your object properties in the same order so that the hidden classes which the compiler uses underneath the hood can recognize that the animal class. Object 1 and object 2 have the same hidden class. That means they have the same properties. However, as soon as you start introducing things in different orders, it will get confused and say, they don't have a shared hidden class. They are two separate things. Internally, this will slow things down. So, in a situation like this, you should assign all properties of an object in its constructor. So, the goal is to add the A and B properties here to avoid this issue, or ensure that we add things in the same order. This is also why there is an issue with the delete keyword. If I delete the property here, it will delete the entire object. Furthermore, I changed the hidden classes, coding them to no longer match up. When it comes to optimizing the compiler, there are small little gotchas, like that which you don't really have to worry about too much. The key takeaway here is that we should write code that is predictable, not only for humans, but also for machines. The more predictable your code is, the better it will be, because there will be no surprises. Throughout the course, we will learn these practices that will help us write optimized code that is predictable and doesn't confuse the compiler. I'm not going to mention every single time that we are optimizing for the compiler. We'll just assume there is these best practices. When incorporated, as I'll show you throughout the course, will help us write fast and efficient code. And again, I'll provide you all the resources, all the links below here if you want to learn more about the topic and truly understand what hidden classes are. It's not something you need to worry about too much. But for now, I'll see you in the next video. Bye bye.